Discuss LeetCode problem number 994, rotting oranges. But before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. So the problem is you are given a grid m by n composed of cells where each cell can be either empty like this one, contains a fresh orange which is value of 1 like this, or contains a rotten orange value of 2 like this one with an X mark. The challenge is to determine the minimum time required all fresh oranges to become rotten. You can go in 4 directions: up, down, left, right. So for each minute a rotten orange turns an adjacent fresh orange into a rotten orange. If not all oranges can rot, the function should return -1. So there could be an island of fresh orange which the rotten oranges cannot reach by using up, left, right, down 4 directions. Then you should return -1. So in this case, in the first minute, these two rot, and then in the next minute, this one goes to the right, or this one come down, or this one goes to the right. So these oranges rot. In the next minute, only this one rots because only this one can go down, and in the fourth minute, this one rots this orange. Let us take a look at the solution. So the optimal approach to solving this problem involves using a BFS to iteratively spread the rot from rotten oranges to adjacent fresh oranges. BFS is suitable here because you can do level order traversal. This character perfectly matches the problem's requirement to spread the rot minute by minute uniformly. So that's why I call this pattern as BF iteration per minute pattern, because each iteration of BFS represent a minute. So you just see how many iterations you have done, and that's the number of minutes it takes to rot all the oranges. So let us take a run through the code line by line. This orange rotting function takes a two-dimensional vector grid representing the state of the grid. So here we initialize the rows and columns to store the dimensions of the grid, and then a queue to hold the positions of rotten oranges using a queue of pairs, int and int, and a fresh count to keep the number of fresh oranges. So in this loop, what we are doing is if the orange will go through the entire grid, and if orange is rotten, we add it to the queue to start the first iteration, and if it is 1, we add the fresh count to keep track, like whether we have rotten all the oranges or not. So this one we have a vector of directions, 4 directions: up, down, left and right, used to explore adjacent cells. This minutes passed is basically the number of iterations of BFS we're going to take to bring down the fresh oranges count to 0 basically. And you loop through the queue, and then at each current level you get the size, the current queue size. So you don't want to include the ones which we are going to add while processing this current level. And so you loop through the current level, get the each pair of oranges which are rotten. So you go in all 4 directions and using this nx and ny, and you check if any of them is fresh, and if it is fresh you set it to 2, and then because this orange will rot additional oranges in the next iteration, so you have to push it, and because this fresh orange converted into a rotten orange, you reduce the fresh orange count, and at the end of this for loop you increase the minutes passed, and then at the end of it, if fresh count equals to 0, then you return minutes passed, otherwise you return as -1. That's it. I'll show you a dry run for the LeetCode problem we saw on the LeetCode website. But comment below if you have any questions. So this one initializing the grid and counting fresh oranges, rotten orange and position 0 0, that's the 2, and then fresh oranges count is 6, starting BFS to spread the rot, processing 1 rotten oranges in the minute, the fresh orange turned out rotten at 1 0 is the second row, the first one that going down, and then 0 1, so the other one, both of them as we saw in the LeetCode thing, 2x's, so those are the ones. So similarly in the second iteration, the one at 1 1 and then 0 2, they both rot, and in the minute 3 the one at 2 1 rots, and in the minute 4 the 2 2 rots, and the count becomes 0. So that's why you return 4. That's it. I will see you in the next video. Bye.